So in this problem, we've asked for the x-coordinate of the point of inflection. And so let's locate our point of inflection as where we change from concave down to concave up. We see that it lines up with the minimum on the derivative and also the 0 on the second derivative. So that's the piece right there that makes this so easy to do it algebraically. We're looking for when f double prime of x equals 0. So we'll start with our first derivative. Our first derivative is 4x cubed minus 6x squared minus 72x plus 0. Our second derivative is then 12x squared minus 12x minus 72. And of course, we're going to set that equal to 0. Some heavy-duty factoring. 12 is common to both, all terms. X squared minus x minus 6 equals 0. Since we still have 12, that's just a multiplier. X minus 3, x plus 2 equals 0. Meaning our zeros are 3 and negative 2. Nothing will make this 0 because it's just a coefficient. So now we're going to plot our second derivative. Our second derivative is a quadratic with zeros at negative 2 and 3. We're just making sure that our second derivative changes signs, and it does. It changes signs at both zeros. So I have 2 points of inflection. My points of inflection are at x equals negative 2 and x equals 3.